Welcome to The Explainer. Today, we're digging into a really fascinating study that uses artificial intelligence to try and predict something fundamental, something that shapes our entire society: birth rates. Yeah, I know. It sounds like something straight out of science fiction, right? But believe it or not, we're diving into a real-world case study where researchers used AI to try and answer that exact question. And they did it using more than 2 decades of national data. All right, so here's how we're going to break this down. First, we'll look at the big picture. Then, we're going to zoom right into a specific case study from Malaysia. We'll meet the AI tools they put to work, check out their report card, and then, at the end, we'll unpack what this all really means. Okay, so first things first. Why on earth would anyone want to predict birth rates? Well, it turns out this isn't just some abstract academic game. It has massive, real-world consequences. It's actually super crucial for for planning our future. I mean, think about it. Governments need to know how many schools they need to build or where to put new hospitals. It's all about allocating resources in a smart way and making policy decisions that end up affecting every single one of us. Okay, so let's see how this actually works in the real world. For this, we're heading to Malaysia. Researchers there got their hands on this incredible data set. We're talking 24 full years of national birth records. A real treasure trove of data. So, with all that data, the researchers set out to answer 4 big questions. You can think of these as 4 challenges they laid out for their AI models, really trying to figure out what's predictable and, just as importantly, what isn't. Now, to tackle these challenges, they brought in a few different machine learning models. But for our purposes, we're just going to focus on the 2 main contenders, the 2 big competitors in this prediction showdown.
So what's really interesting here is that these 2 AI tools have totally different ways of thinking. On one side, you've got linear regression. The best way to picture it is like a simple ruler, just trying to draw a straight line through the data. And on the other side, you've got XGBoost. This thing is way more sophisticated. It's like a whole team of detectives, constantly learning from each other's mistakes to uncover these really complex, hidden patterns.
All right, so the stage is set, the data is prepped, the models are trained and ready to go. The big question is, how did they actually do when they were put to the test? Well, the results are pretty surprising. First up was the big one. Could the AI predict the actual raw number of births? Now, to grade them, the researchers used what's called a prediction error score. It's pretty simple, it's just a number that shows how far off the predictions were. And for this score, the lower the number, the better. So first, let's look at our simple ruler, the linear regression model. It came back with a prediction error score of, wait for it, over 4 billion. Yeah, that is a gigantic error. And it just goes to show that a simple, straight-line approach really couldn't get a handle on the messy, complicated reality of birth trends. But then, check this out. Our team of detectives, XGBoost, was just dramatically more accurate. Its error score was only 54 million. Now look, that's still not perfect, right? But it is a huge improvement. It really proves that for a complex problem, you need a more sophisticated tool. All right, on to the next task. This time, instead of predicting an exact number, the job was a little easier. The AI just had to look at a year and classify it as having either a high or low birth rate. And this is where things got, well, really interesting. What happened? It got a perfect score, a 1.0. 100% accuracy. And your first thought is probably, wow, that's amazing. But, in the world of data science, when you see a result that looks too perfect, that's usually a huge red flag. And this is a textbook example of a classic trap in data science called overfitting. The best way to think about it is like a student who crams for a test by just memorizing the answers on a practice sheet. They'll totally ace that specific sheet, but the second they see a new question on the real exam, they're lost. And that's exactly what happened here. The model didn't learn the patterns, it just memorized the answers it was shown. Okay, so let's move on to the third challenge. This one was a little different from the others. The question was, could the AI predict a newborn's sex if it only knew their birth year and their ethnicity? The result? A pretty dismal 3% accuracy. I mean, you could do better just by flipping a coin. This basically just confirms what you probably already guessed, that things like the year you were born or your ethnicity have pretty much zero power to predict a baby's sex. That's just not how biology works. So, Let's look at the final report card here. Could the AI predict the number of births? Kind of. It was partially supported. Did it find differences between ethnic groups? Yes. But predicting the sex of a newborn? Absolutely not supported. And classifying birth rate periods? Well, that was a yes, but with a huge asterisk next to it because of that overfitting problem. Okay, so let's pull back and look at the big picture again. What does all of this mean? What are the big lessons we can take away from this whole experiment about using AI to predict major life events? You know, this study taught us some really crucial lessons. For one, AI is an incredibly powerful tool, but it is not a magic crystal ball. It's also clear that more complex models, like our detective XGBoost, are often way better for complex problems. And maybe most importantly, we learned that perfect results can be really deceiving. You always have to watch out for things like overfitting. And of course, some things just can't be predicted from this kind of data. And really, this brings us to what might be the single most important lesson of all. The researchers themselves were very upfront about this. Their dataset, as big as it was missing some really important pieces of the puzzle. It didn't include things like socioeconomic status, the mother's age, or whether people had access to good health care. And those factors could have told a much richer, much more accurate story. At the end of the day, the AI is only as good as the data you feed it. So this leaves us with a really important final fat to chew on. As AI gets better and better at predicting things about our world, and as we rely on it more and more to understand our own society, what are the big, important questions that we might be forgetting to ask? What are the limitations we're not seeing?